All right, this might be one of the longest videos yet, so I hope you are ready for all help with adding and subtracting when we solve and model equations. So before we get started, there are a few things that I want to add to these notes just so we are kind of aware of when we're drawing these tiles, what we are showing, what we are representing. The first one is when we draw a big, long, unshaded rectangle. This represents an X tile. Okay, remember X is one of the most common variables. What we're doing today is going to be solving for X. So whenever we see X in a problem, if I ask you to draw tiles, to draw an X, you are just going to draw, again, a big unshaded rectangle. Now, if in that problem I am adding a number to my X tile, when I have addition, all I'm going to use is an open dot. That represents addition. So if I'm subtracting, I'm going to use a closed dot. Okay, so when we read these word problems, we've done a lot of practice with when we see some keywords, circling them and showing what that represents. But the more we deal with variables, there's a different strategy that I like to use for this. So I'm going to use that strategy for you guys today. And it's going to be labeling the variables in each problem, showing what they represent. So our problem says that Casey has been to the park 3 more times than Kendall. Casey has been to the park 5 times. So how many times has Kendall? And then after it has X. So that means that Kendall is represented. That is our unknown variable. Our unknown number is X. So how many times has Kendall been to the park? And then I see that I have 2 options here. So I have X minus 3 equals 5 or X plus 3 equals 5. So I'm going to go ahead and I'm going to label in both of these equations everything that I know is true from this problem up here. And I'm going to start with the variable. So I know that Kendall is represented by the variable X. So everywhere I see an X, I'm going to put a K for Kendall above it. Now, the other thing that I know is true is that Casey has been to the park 5 times. So anytime I see a 5, I'm going to label it with a C for Casey. Okay, then the very last thing, the only thing that's different between this problem is one of them is subtracting and one of them is adding. So I just need to figure out, am I taking Kendall's number and subtracting from it, or am I taking Kendall's number and adding to it? So if Casey has been to the park 3 more times than Kendall, that means Casey has been there more times than Kendall has. So Casey's number should be bigger than Kendall's. So when I look at this, I can already kind of figure out what X should be in both of these problems. Like, for example, in the first one, I know that a number minus 3 has to give me 5. Well, I know that should be 8, right? 8 minus 3 gives me 5. So this would mean that Kendall's been to the park 8 times, Casey's been to the park 5 times, but I know that Casey has been there more than Kendall, so it wouldn't make sense that Casey would have a lower number than Kendall would have. So this is not my equation. But on this one, again, I can already kind of figure out what X should be. If I need a number and I add 3 to it to get me 5, well, that number would be 2. Now it shows that Casey has been to the park 3 more times than Kendall. So this is going to be our equation that we're using. X plus 3 equals 5. Now we're going to take this equation and we're going to solve it using tiles. We're going to solve it algebraically as well. And I'm going to start with the tiles. Now, the first thing you'll notice is on this tiles, there's this big, dark, solid line down the middle. That dark, solid line always represents our equal sign. So I'm going to draw exactly what is on the left side of that equal sign. So in fact, I'm going to cover it up. So there's my equal sign. I'm covering up everything except for the left. So I know that the only thing on the left side of the equal sign is X plus 3. So I need to use these tiles up here and draw X plus 3. So remember, for my X tile, I'm going to use a rectangle line. And then since I'm adding 3, I'm going to use 3 unshaded circles. So 1, 2, 3. Now I need to draw what's on the right side. So I'm going to cover up everything except for what's on the right. And all I have over here is 5. So I'm going to draw 5 unshaded circles. 1, 2, 3, 4, 5. Okay, now our whole goal is we want to figure out what does this X represent, okay? Now again, I already know that we know it should be 2, but let's show how using our tiles we represent this. Now, the X. right now, and I use this saying a lot, is we want to get rid of what is bothering the x, what is all up in the x's space. So right now I have 3 unshaded circles that are bothering my x tile. So to get rid of these 3 unshaded circles, I have to do the opposite of 3 unshaded circles. So the opposite would be 3 closed circles or 3 shaded circles. But now what I've done is I want us to think about that scale that we had yesterday. And remember, when we balance equations, I want that scale to be equal. And before I did this right here, those scales were equal. But now I've added 3 closed circles. So now this side is more than what this side is. So I've got to rebalance it out. So in order to do that, if I added 3 closed circles on the left side, I have to do the same thing on the other side. I have to add 3 closed circles. Now, every closed and open circle cancels each other out. So those cancel each other out, those cancel each other out, and so do those. On our right side, those cancel each other out, those cancel each other out, and so do those. So my answer is going to be whatever I'm left with on the left and the right side. So on the left side, all I have left is x. And then this line represents my equal sign. And then all I have left are my 2 open circles, which represents 2. So I know that x equals 2. So if I was going to solve this algebraically, which means no tiles, no pictures, I'm going to start with my equation. So x plus 3 equals 5. And I'm going to draw a T chart. So I'm going to put the vertical part of my T straight through my equal sign, just like I did over here with my tiles. And then I'm going to underline my problem. So I've separated what's on the left and what's on the right. Now, when I solve it algebraically, I want to circle what is bothering the x. And what's bothering the x here is this plus 3. So I need to do the opposite of plus 3. So the opposite of adding would be subtracting. So I'm going to subtract 3. And what I do to one side, I have to do to the other side. So subtract 3. So plus 3 minus 3, those cancel each other out. So I'm left with x on the left. And then 5 minus 3 gives me 2. Okay, for the check, what I'm going to do is I'm going to take my original equation, x plus 3 equals 5, but now I'm going to substitute in what I think the answer is. So I think that x should be 2. So 2 plus 3 equals 5. That is true, so check. And then last but not least, the graph. The graph is easy peasy, lemonade squeezy. All we have to do is figure out, well, what did we think that x equals? X equals 2. So I put a nice dark closed dot on the 2, and that's it for the graph. Okay, let's try another one. I'm going to actually jump to the back. Okay, on the back, it says that Finley took $5 out of her piggy bank and had $2 left. How much money, X, did she have in the bank before her withdrawal? So I know that X represents the before. So I'm going to use that when I label my equations here. So I have 2 different equations. 2 equals x minus 5 and 2 equals x plus 5. So I know that the x represents the before. So here is the before and here is the before. I know that when she was done, she had $2 left. So this is what was left. This is what was left. So when I look at these 2 problems here, I know that something minus 5 has to give me 2, which I could figure out. But when I look at this one, I see something plus 5 gives me 2. And that one really doesn't make much sense because what am I going to add to 5 to get 2? So this is going to be my equation right here. Now, when I look at this equation, this one's a little bit different because instead of putting my variable on the left side, my variable is on the right side. But the good news is that doesn't change how we solve it. It's still going to get solved in the same way. It's just flipped on the opposite side. So let's start with our tiles. Again, we said this long dark line down the middle means equal. So I'm going to put an equal sign there. I'm going to start by drawing what's on the left side of my equal sign, which is just 2. So I have 2 open circles. 1, 2. What's on the right side of my equal sign is x minus 5. 5. So I need to draw that using my tiles. So here is my X tile. And since it is -5, I need my closed circles for this one. So 1, 2, 3, 4, 5. Okay. So again, I haven't solved anything. I've just drawn exactly what I see. So my goal is to get rid of what is bothering the X. So right now I have 5 closed circles that are bothering the X. So the opposite of having those closed circles would be to add open circles. So 1, 2, 3, 4, 5. So remember, if I add 5 open circles on this side, I have to do the same thing on the other side. 1, 2, 3, 4, 5. Now I want to go through and I want to get rid of any closed and open, goodness gracious, closed and open tiles that I can. So there's some, there's some, there's some, there's some, and there's some more. But over here on the left side, I don't have any closed and open circles that I can get rid of, which is totally okay. That is fine. I still have gotten rid of what's bothering the X, so I can write what my final answer is. So on the left side, I have 1, 2, 3, 4, 5, 6, 7. Remember, this means equals and my X tile. So 7 equals X, or I could rewrite this as X equals 7. Okay, let's look at it algebraically. I have 2 equals X minus 5. Again, I'm going to set up my T-chart. So I'm going to draw a straight line through the equal sign, a horizontal line underneath. I'm going to circle what is bothering the X, which would be -5. I'm going to do the opposite. So the opposite of subtracting 5 would be adding 5. What I do to one side, I have to do to the other side. So I'm going to cross out, cancel out my -5 and my +5. So I'm just left with X. And then 2 plus 5 would give me 7. So again, let's go ahead and check. So I have 2 equals X minus 5. I'm going to plug in what I think X is. So 2 equals 7 minus 5. And sure enough, 7 minus 5 equals 2. Check. And then again, to graph, I'm just going to put a closed dot on what I think X is. And I think X is 7. So I'm going to put a closed dot there.